So this is from 2017, question number 33. In an in vitro dehydrogenation reaction of succinate catalyzed by succinate dehydrogenase, malonate is added. Which one of the following curves represents the effect of malonate on the catalysis of succinate dehydrogenase? So this is an enzyme catalyzed reaction. The substrate here is succinate and the enzyme is succinate dehydrogenase, and we have also added malonate. So malonate is an extra substance which is being added. Normally we would say in enzyme kinetics. So if this is the substrate, this is the enzyme, and this could be the uh, inhibitor, we can say. So, which one of the following curves represents the effect of malonate on the catalysis of succinate dehydrogenase? So, to answer this question, first of all, we see the structure of both malonate and succinate. So, you can see there is a very similar structure. Both malonate and succinate have this carboxylic group at their both ends. Malonate, and this is for succinate. You can see both of them have carboxyl groups at their both the ends. Just the only difference is that succinate is longer by carbon. The chain is longer by one carbon compound, and malonate is a little shorter. So this type of substrates or inhibitors in which they are structurally kind of similar, they belong to the competitive inhibition. So what is that? They are structurally similar to substrates and hence competes with the substrate to bind to the active site of the enzyme. It cannot bind to the enzyme substrate complex, but it will compete with the substrate for the active site. Either the substrate can bind or the inhibitor can bind. Increasing the substrate can overcome the inhibition as well as the efficacy of the enzyme is not affected. Okay, so more substrate is needed to achieve half of Vmax and hence Km increases, but Vmax remains the same in these type of inhibition. So this is the slope. So you can see blue line indicates the reaction without an inhibitor and red line with inhibitor. So here the slope changes, but there is no change in the y-axis. So y-axis in this type of reactions indicate the Vmax. So Vmax is unaffected, but Km, which is denoted by the slope, that gets increased. You can see the slope is getting steeper, therefore the Km gets increased, but Vmax remains the same. So you have to look for this kind of a graph in which Vmax is same. So here if we go back and okay, before going back, so this is the uh, so you don't need to know the entire reaction, but for the sake of for the sake of explanation, so this is enzyme plus substrate, which is succinate, and there we get the enzyme substrate complex, the which converts the succinate to fumarate, which is the product. But if we add the inhibitor, malonate, it will bind to the enzyme, but there would be no reaction, no further reaction, and no conversion of the substrate to the fumarate. Just what it would do, it will block the enzyme site so that succinate cannot bind. And because they have similarity in structure. So let's go back to the question. It was so in this type of reaction we have to look for the graph in which the Vmax remains the same. So here we can see the Vmax is the same for both the uh, slopes, for both the lines. Okay, the Vmax is same although the slope is changing. Here Vmax is different. Okay, one is here and one is here. Here also Vmax is different. Here it is completely, this is a different kind of graph. So A would be the answer for competitive inhibition and this type of reaction. So this indicates this is same, and therefore Vmax is same, but the slope is different, the x-intercept is different. Therefore, this is a example of a competitive inhibition.